Welcome back to our custom deep dive. You know that feeling when you walk into like a sprawling airport terminal or a massive casino and the atmosphere just kind of hits you?
Oh, absolutely. The background music, the boarding announcements, it all just blends in.
Right, it feels totally organic. We're so used to it that we rarely even process it as technology.
Yeah, but making sound that invisible actually requires some, well, aggressively heavy-duty engineering.
It really does. So today we are tearing into the technical specs of the QSC AD-S10T surface mount loudspeaker. We pull this straight from an HDTVSupply source page to figure out how they, actually pull that illusion off.
And looking at the raw muscle on this thing, I mean, it's kind of intimidating.
Right. The spec sheet lists a peak maximum of 122 decibels. That is literally as loud as a thunderclap or a live rock concert. Why does a background speaker need to be that aggressively loud?
Well, because in commercial spaces, distance is really your enemy. It's not about blasting people in the front row at all.
You're trying to push sound through a massive, noisy environment?
Exactly, but raw volume just isn't enough, which is why the power delivery system on this is so crucial.
Yeah, I noticed it features this dual capability setup, a standard 8-ohm bypass and a 70 or 100-volt transformer. Now, I understand the 8-ohm bypass. That's basically your standard home audio setup.
Right, for a single room.
But why introduce high-voltage transformers for background music? Like, what does that actually do?
Think of it like water pressure in a really long hose. If you daisy chain 50 standard 8-ohm speakers together down a mile-long airport concourse, what do you think happens?
The ones at the end get weaker.
Yeah, the speakers at the very end of the line are going to sound like a whisper compared to the first one.
Oh.
The voltage just drops.
Oh, I see.
So by using a 70 or 100-volt transformer, the system pumps the audio signal at a much higher pressure.
Okay, so that high pressure ensures the speaker at terminal Z gets the exact same volume as the speaker at terminal A.
Precisely. It lets the system scale up seamlessly over massive distances without the volume fading out.
That makes sense.
Yeah.
But wait, chaining 50 high-pressure speakers together introduces a massive acoustic nightmare, doesn't it? Cavernous rooms are notorious for becoming, garbled echo chambers.
No, they definitely are.
So how do they actually control all that power? The spec sheet highlights something called Directivity Match Transition, or DMT. But honestly, that just sounds like pure marketing jargon.
It totally sounds like it, yeah. But it's actually the physics solving the echo problem. You have two main components making sound here.
Right.
A large 10-inch cone pushing out the deep bass and a tiny 1-inch driver handling the high frequencies. Naturally, those two parts throw sound into the room at entirely different angles.
So you get weird spots in the room where you only hear bass,
Yeah.
and other spots where the high notes just pierce your ears.
Exactly. But DMT physically aligns and matches the dispersion patterns of both those components right at the point where their frequencies overlap.
Oh, so by forcing them to blend perfectly, the speaker pushes out a consistent 90-degree cone of sound.
Right. Meaning there's no sweet spot, whether you are sitting dead center under the speaker or like way off by the wall, the announcement sounds exactly the same.
Wow. Okay, but that precise cone of sound
Yes.
is completely useless if the speaker itself moves. Which I guess brings us to the physical hardware.
Yeah, the physical ruggedness is a huge factor.
I do have to challenge this part of the spec sheet, though. It spends a lot of time bragging about weather-resistant sealed connectors, like the 4-pole Euroblock to stop moisture.
Right, the IP54 reading.
Yeah, and this award-winning X-Mount system that guarantees no slippage over time. But wait, this thing only weighs 31 pounds. That's heavy for a home speaker, but I could carry that in one arm. Why is an anti-slip mount the headline feature?
Really, it comes down to gravity and liability. You aren't placing this on a bookshelf in your living room.
That's true.
You are suspending a 31-pound block of dense magnets and electronics 20 feet in the air directly over crowds of people eating dinner or waiting for a train.
Oh, wow. Okay, fair point. Hanging it horizontally or angled down from a ceiling changes the math entirely.
It does. Long-term mechanical stability isn't just a perk, it's a critical safety requirement. And from an acoustic standpoint, no slippage means that carefully engineered 90-degree sound cone stays exactly where the technicians pointed it.
Ah, of course. Because if the speaker sags even an inch over 5 years, you suddenly have dead zones in the room again.
Exactly. All that DMT technology goes out the window.
So it's this perfect balance of extreme acoustic precision and rugged industrial practicality. Just pumping high-pressure audio flawlessly across massive spaces, safely locked into place.
It is the ultimate invisible infrastructure.
It really is. So for you listening, next time you're waiting at a bustling transit terminal or a sprawling restaurant, look up.
Mhm.
Try to spot one of those sleek enclosures hiding in the rafters. And it makes you wonder, as spatial audio and AI sound mapping become standard, will these invisible systems eventually be able to track exactly where you are in that terminal?
Oh, to give you direct audio.
Yeah, like beam a personalized boarding announcement directly to your seat without anyone else hearing it. Something to think about.